Pablo.
Andrea. Paula, Sofía, Mariana, Rafael, Daniel, Guillo. Okay. Listen about the activity. I checked some of your grades, and well, some of you got 90s, 100s. That's okay, but some others got 50, 46, something like that. So the idea here is that teacher Tiberio, the coordinator of the subject of calculus, allowed you to have another day to do it. So what I did was I granted you another day to do the activity, and also another attempt. For example, you already did 5 attempts. You have another one if you want.
¿Y si sacamos 100, profe?
Claro.
A mí hace cuenta que yo lo hice una vez, lo empecé la primera vez y como que yo me saqué de lo que significa así, que la Paola como que cerró y ya lo regresé y se había cerrado el examen. Hice 2 intentos que sí iba a hacer bien y luego el tercero me cerró.
Okay, no, you want to produce grade, do it again. Do it again if you want to.
O sea, pero seguimos teniendo las oportunidades. Por ejemplo, si yo hice nada más 2 oportunidades,
Then
tengo
you
las
have 4 more. So there will be 6, and the total will be 6 now. If you did 5, you have 1 more. If you did 2, you have 4 more. Okay? But if you already got 100, then that's up to you. Also, some of you told me that there were like 1 or 2 questions that had a mistake in the answer. So if that is the thing, send me an email with the correct answer, with a picture of the exercise and the correct answer, and I can correct indirectly on black. Okay? Yeah.
Tenemos que saber lo que viene en el diagnóstico.
¿Tienes una foto en el examen?
Well, it's not going to be like that in the quiz, but I'm going to start using it in the next couple of years. For the limits, yeah. So, check that. Yeah. Fine. Before we continue with the topic, we're going to check the last 2 question activity, okay? They're a little tricky. This activity is going to be due Friday, okay? You remember, this Friday is also the first quiz. The first quiz is going to include the previous topic, this one, and the next one. Okay, so we'll do 3 or 4 topics. Okay, so ready? Fine. Okay, last class on Friday we did some of this in class, but let's do number 8 and number 9 together so I can answer your question and everything. Number 9, you have the limit x approaches 1 from the left of 1 over x if x belongs to x into 1 not included, and e to the x if x belongs to 1 included to infinity. This is a piecewise function, remember? Now, if you observe, here is the 1 here, and then it changes to this one. Do you remember what's the name of that value? Where it changes from 1 to no, step point, yes. This value is called the step point. By the way, yeah, on the quiz I'm not going to ask theory of this, but still, you need to try to remember because in the class I'm going to start using the names and everything. Okay, so if it says the limit x approaches 1, but from the left, remember the 1 is also a step point, so I need to choose. Do I choose this one or that one? The first one. Why the first one?
Because it's like from minus to 1.
Exactly, because it's from the left side, which is before the 1. So what I do, I just evaluate. It will be 1 over
Minus 1.
no, minus.
I know, sorry, 1.
Minus 1. Do I need to put from the left here?
No.
No. Why not?
Because it's this side.
Because you have the limit.
No, the real reason is, if you remember also, I told you that if, for example, this value is a problem in the domain, that is, this value makes this non-existent, then you need to check what happens left and right. For this one is in the domain of this function.
Yeah.
Normally, 1 over 1 is 1. So, I don't need to put the little sign. I just evaluate. 1 over 1 is what? 1.
Es en el de la de arriba,
Yeah.
pero no está incluido el 1.
Doesn't matter. So I'm checking from the left.
Ah, okay.
So, if it was a 0,
If it was a 0, this was a 0, then you need to check whatever the sign says.
so
Left or right.
0 minus.
Yeah, because it will be infinity or negative infinity. Next one, limit x approaches 1, but from the right. So I choose what?
Choose the one of
The second one, so it's going to be e to the 1. I need to put also the little sign, so it's going to be equal to e. You can do it like that, e. Now, yeah.
Why in the other one, in the first one, we put 1 over 1?
Because that's the function, 1 over x.
Ah, okay, okay.
I need to evaluate 1 over that value. 1 over 1 is 1, directly. This one, e to the 1, is just e. No need to put a decimal, just leave it e. That's fine. The full limit doesn't exist. Why not?
Because it's different. It's 1 and then
Because they are different. Exactly. Limit from the left, limit from the right, they are different. Doesn't exist. Do you remember how to graph this function? Well, you're honest. Honestos. Okay. It's a piecewise function, so I need to graph piece by piece. First, 1 over x. At least, do you remember how to graph 1 over x?
No, I don't.
Profe,
Yeah.
¿cuándo son las asesorías?
El martes,
Tuesday and Thursday.
What hour?
No.
Good. So, I want to graph 1 over x. You can use points for that. The first one will be 1 comma 1, minus 1 comma minus 1, and the graph is going to be
From minus
this part and the other branch. Yeah? Now, do I leave it like that or do I need to erase something? Exactly. It says this is the domain for this, so I need to stop at 1, that is here. And then here, is it going to be full dot or an empty dot?
Empty.
Empty. And erase this part. Okay? Why empty? Because it's parentheses. The second one, e to the x. Because it says that it ends at 1. This is from minus infinity to 1. The rational. So it's going to be rational from minus infinity in x until 1. And then from 1 to infinity to the x. So now I need to graph
Pero
it.
profe, sí, es positivo. O sea, y siempre va a ser elevado.
No. Okay. What?
Pero no entiendo el dónde va el 1 al infinito. La de abajo.
Tienes que sacarle.
Fine. Second one. E to the x. E to the x is an exponential. Exponential. Remember, special point 0, 1, 1, e. E is 2.7. Somewhere like this. So the graph is going to be like this. Then goes up.
¿Cómo me puedo acordar de eso?
Pero it is from 1, right?
Yeah, that's a full graph, but it says it starts at 1, full dot, so you need to put the point here and then erase this.
Oh, what you say.
That's e to the x, and the other one is 1 over x. Listen, I know that you forgot all those graphs, but remember, you need to study. Because in discipline, most probably, yeah.
Oh, teacher.
¿Qué? ¿Cuál fue la pregunta?
Que van a venir las gafas.
As I remember, the first partial of math 3 was about this kind of graphs.
Ay, pero fue más free.
You're in math 5?
Por eso hace un año.
3, 4, 5? Or 3, then
¿Se
4.
acuerdan que había historia? Ay, qué bien.
Entonces ahí otra vez
And you need to observe that in this case, for example, the limits comply with that. So the limit from the left ends at 1. And the limit from the right at e.
Por eso la perdiste, porque está chapa.
Ah, no, o sea,
Good. Next one. It says limit x approaches negative 2 from the left of x plus 2 over x squared minus 4. This one is tricky, so I have to solve it. In this case, for example, if I were to check from the left or from the right, the answer is going to be 0 over 0 still. So next is, what I do is this. If I were to evaluate here directly, it's going to be 0 over 0. That's a special kind of limit. Okay, that we're going to see later this week on Thursday or Friday, I think. So what I'm going to do is this. This function, observe it. Can I simplify it?
Yes.
How?
Divided by 2. By 2, 1, and 4, 2.
No. Exactly. This here says different squares. Then you cancel that. Okay? So I simplify that. I evaluate it again, and the answer is going to be negative 1/4. Okay?
¿Con qué sustituye la X?
¿Mm?
¿Con qué sustituye la X?
Equivalence.
Ah,
Okay. Listen, don't worry about this right now. We're going to dedicate an entire class to explain this kind of limits. Huh? So, right now, don't worry. Well, I'm going to explain it later. A little more thoroughly. So, if that one gives you that means that from the left and the right should be the same answer. Okay?
Ay, pero, ¿qué? Espere, 2.
Again. There will be a class where I'm going to explain these kind of limits with 0 over 0 a lot more thoroughly. That's why I explain right now. So, if I think that if I can see it on Thursday, then maybe yeah, perhaps not. Perhaps in the next quiz number 2. I'll try to make sure that. Yeah.
Right now we just denote the 0 over 0 and do this.
The idea is that actually you take 0 over 0 and include this. But again, I'm going to explain it.
¿Y cómo se grafica, pues?
Ah, okay. Basically, it's that if you evaluate you take 0 over 0, see if you can see that. And you can see if you have a number. Okay. If I want to graph that,
Profe, una duda.
yeah.
¿Y por qué ahí no se hace lo de menos 2 por la izquierda al cuadrado menos 4?
Because the answer is going to be still 0.
Ah,
Because it will be 0 over 0 from the left and from the right, so it's not conclusive. It's better that way. But only when you pass 0 over 0. Okay, but again. There will be an entire class for this, so don't worry. Fine. If I want to graph this, what I'm going to do is graph the one that I've got, this one. So 1 over x minus 2. What kind of graph is that? Something like this, a rational. But move to the spaces to the right, sorry.
To the right?
Yeah, to the right.
¿Ese es en el 4 el asunto?
No, what it means is that it's a 2. The asymptote is a 2. Why? Because of the denominator. The 1/4,
Ah, se toma
it
ese.
means that there is a gap, an empty dot. Where? At minus 2.
Why a gap?
Because of the 0 over 0. That means that I'm checking at minus 2. So at minus 2 you have a gap. And the limits tell you that the graph approaches minus 1/4. Here is minus 1/4. From the left, from the right, and the full limit.
Dios. Profe, pero son cuartos lo tomaste de...
Yeah, because that answer is the limit. The y value. Okay?
Pero 1/4 es como el punto
Igual.
donde está la curva.
So this gap will hold is minus 2 comma minus 1/4.
Profe, pero ¿por qué la menos 2? O sea, ¿por qué tener
I'm checking that. Eliminate that. Okay?
Profe, ¿necesito explicar esto?
No, again. This limit is a special limit. I'm going to dedicate one entire
No, se
class.
refiere a las gráficas. O sea,
Normal graph, then yeah.
Mister, y 1/4 en de X, ¿cuál es el valor de Y? 1/4 y 1/4.
No, minus 2, 1/4. Minus 2, 1/4. Good. Yeah. Be careful. Ahora no
ln de 0, pues te va a dar. A ver, ¿quieres sacar tu pie de graph? Aquí está.
¿Qué no para el límite tenés que quedarte en el -1?
Ya, -1/4, igual.
En el eje de Y.
Ya. Se vale igual. X igual.
Se dice igual.
Ok.
Ay, no sé. O sea, de aquí no existe. Porque esa casi no se explica. Bien, pero de todas maneras. O sea, si es una. Es la de texto, es la de. Pero aquí es aquí le vas a decir restas 2, pero el logaritmo natural de .0001. Espera, este es infinito.
Okay. Next topic then. Fine. We're going to see how to evaluate a limit at infinity, but analytically, that is without the graph. What do I mean by that? You remember, we already saw in the first activity that sometimes you have infinity or negative infinity. Yes. Negative infinity. And then the idea here is to solve them, but without the graph. Do it easy. Ready? Good. Ready? Fine. So, for example, if you have a limit of a function, any function, as to infinity or negative infinity, the very first step to do is to substitute directly. Okay? Substitute the infinity in the function. Now, it depends what kind of function you have on what the procedure is going to be. The first type of function we're going to do today, the rational functions. Okay? That is, if when you're evaluating a limit as x approaches plus or minus infinity of a rational function, that is, a function over another one. You obtain this, then. Okay. I want to give you an example for that. Imagine that you have a rational function, that is, a polynomial over a polynomial. Example, let's say that I have the limit as x approaches infinity of something as 2x minus 1 over x plus 2. Okay? That's a rational function. because it's a polynomial over a polynomial. Okay? If you have that kind of limit, you need to evaluate first. That is, put the infinity instead of the s. For example, let's see what happens here. If I evaluate directly, what do? It will be 2 times infinity minus 1 over infinity plus 2. Infinity is a really big number, like a constant. Okay? No need to put the value, just put infinity. Infinity times 2, still infinity. Minus 1, still infinity. So, infinity over infinity plus 2, infinity. Okay? When you obtain that, that's not an answer. That is not an answer. That's called an indeterminate form. Indeterminate form. What does that mean? That is not an answer. You need to do something else to obtain a real answer here. A number or just infinity, for example. So, that's when you happen to obtain this. If you have that, then the first thing is to check in the denominator of the function which is the x with the highest power. The x with the highest power. In this case, for example, which is the x with the highest power? X. X. So again, check for the x with the highest power. Could be x squared or x to the cube. It depends on the example. With the highest power. In this case, I found that it was just x. There's no x squared, there's no x to the cube, so it's just x. In the denominator. No, it should be the denominator. Not denominator, not numerator. Denominator. Number 2 is divide each and every term of the function by that x with power and everything. So in this case, for example, I got that. I found that the x with the denominator is the one with the highest power. So what I'm going to do now? I'm going to divide each and every term by that x. So it's going to be like that. The limit, again, as x approaches infinity, of 2x over x minus 1 over x over x plus 2 over x. I'm taking every term of the function and dividing by that x. Just the x. If it was x squared, then by x squared. If it was x to the 5th power, then by x to the 5th power. Next step would be to simplify. Simplify and solve the limit again. So in this case, for example, can I simplify? Yes. So limit, no. Not like that. 2x over x is what? 2. Minus 1 over x stays like that. Over x over x, 1 plus 2 over x. I simplify.
Yes.
After I simplify, then I evaluate again. So it's going to be 2 minus 1 over infinity over 1 plus 2 over infinity. Now, pay attention to this. If you have, for example, like this, 1 over infinity, any constant by a really, really big number, what do you get? What's the tendency? A very small number, yeah. 1 over infinity becomes 0. Just 0. We're going to leave it as 0. So leave it. Yeah, but we're going to leave it as 0. So this becomes 0. This one also becomes 0. So you have this one. 2 minus 0 over 1 minus plus 0. 2 over 1, which is 2. And that's an answer.
So that's what will be Azu.
Well, if you are dividing a constant, then you
And what happens if the infinity is not?
then you divide it.
So if you have infinity over 2, that would be because you can see.
We'll do an example like that. I just substitute again. That I simplify, substitute again, and then this becomes 0, and this becomes 0. Questions? Yeah. Yeah. So you do this and then the same thing.
Just the same because it's not minus. Just the same.
If it was, for example, 1 over minus infinity, it's still 0. It doesn't change because this is just 2. We'll do an example with minus infinity.
What is the infinity?
We'll do an example like that. Okay. Can I erase this part?
Yes.
No sé, no traigo reloj. 12:34. Pesado.
This is just the beginning.
¿Mande?
This is just the beginning.
Modo. Aguantar.
Okay. On. This one. Limit x approaches negative infinity of that rational function. In this case, for example, you want to substitute again, but to make things simpler for you, it's a rational function. You have infinities, so we're just going to say that it's going to be infinity over infinity. Okay? Right now, I don't care about the sign because the answer is going to be given by the procedure. So this is equal to infinity over infinity, and then we continue with the procedure. Okay. It's just this, just to say that this is the type of limit that it is, infinity over infinity, to justify the next part of the procedure. Then, in the denominator, yeah.
So every time we see an infinity in the x, we have to do that, like we don't even have to check it.
If it's a rational function.
Okay.
If it's a rational function. If it's something else like a polynomial or an exponential, then it's different. So in this case, correct. Okay. This one. Question?
So if you don't ask us to justify what is all of that, if you know,
Now the idea is this, that you have this kind of limit. Okay? You can say, this is a rational function, a rational, something over something. This is infinity. Directly, the first step is to put it like that. Infinity or infinity. And then the next step is to do all of that, to find the real answer. Okay? So, limit x approaches near to infinity. In the denominator, now you have x to the square and 3. We use the x squared. Yeah, I don't care if you have x to the cube in the numerator. No, it's from the denominator, the highest power, x squared. And divide everything by that.
So x cubed over
X to the cube over x squared plus 2x squared over x squared plus 1 over x squared over.
Then we simplify.
And then you simplify. Even if you have a constant with the x squared, no, I only divide by x squared. Okay? Just the x squared, just the x. And simplify.
x plus 2 plus
X to the cube over x squared, x plus 2 plus 1 over x squared over 1 plus 3 over x squared.
Yeah.
Substitute again with the minus infinity. So minus infinity plus 2 plus 1 over the square over 1 plus 3 over the square.
0.
This becomes 0. This becomes 0.
Why do we choose x x cuadrado?
Yeah. From the denominator. From the denominator, the x with the highest power. So, yeah. Minus infinity, negative infinity, plus 2, still negative infinity. Divided by what? Negative infinity. No,
So the answer will be negative.
that's the answer.
So if we have an infinity on top, it's always going to be that.
If you were to have infinity on the bottom, the answer is 0.
But always, no matter what.
That's the next part. Questions?
No.
No?
Correcto, vamos a tener que graficar eso después o hacer la respuesta.
Profe, hoy me perdí en el que quedó menos infinity más 2. O sea, el más 2, ¿qué le pasó?
Nothing. Negative infinity plus 2, the 2 doesn't matter.
Ah,
2 is a number, a very small number compared to infinity.
Ah, ok, ya.
So minus infinity plus 2, minus infinity. Okay.
Luis, dale,
Profe.
No.
Profe, le puede subir los grados al aire acondicionado. Muchas gracias. Es que estoy enfermo.
¿Qué? Es como para la cara.
Osvaldo, ¿por qué estás usando tu celular? No.
Ah, sí, pero...
Se llama celular eso. Se unas como alumnos.
Okay. Fine. Now the second type of functions are just polynomial functions. Okay, we go to an example. When you have a polynomial is no denominator, of course. If you evaluate that and for any reason you obtain infinity minus infinity, you need to do a similar process, like the rational. But instead of dividing the denominator, you need to factor and then divide the rest. You'll see what I mean with the example. Can I read this part?
Yeah.
Teacher,
Yeah.
David, why does the result menos infinity? O sea, porque de la nada estaba menos infinito más 2 y después como que...
Negative infinity plus 2 negative infinity. Because the 2 doesn't match. And divided by what?
¿Y la cancelación
¿Son las mismas reglas para las polinomios?
Basically.
Sí, ¿no?
Okay. Here, for example, we have polynomial. It says limit x approaches infinity of 3x to the cube minus 2x squared plus 1. What do I do? First step is to evaluate. Evaluate, yes.
Oh, wait.
No. First evaluate. First evaluate. You do evaluate first. So, if I evaluate directly, it will be 3 to the cube minus 2 times infinity to the square plus 1. Infinity to the cube, infinity times 3, infinity. Minus 2 times infinity, infinity plus 1, doesn't matter. Doesn't matter. So you have that. Now you may think, okay, this is going to be 0, but no, because in some cases this infinity is bigger than the other one, or vice versa. So we need to do the process. That's the idea of the process, to check what will be the answer at the end.
How can an infinity be bigger than another infinity?
It mostly depends on the power.
If it were to be
Pero si infinity was infinity, we could like do the process. Or
Okay, you can. Do you mean as skipping the step?
no. If I know result where infinity plus infinity instead of minus.
Okay. Yes, that happens. Okay. And that's also the only problem when you have the Tema.
Okay.
You can just cancel them. But you have
Okay, we don't do anything.
Good. Okay. Again, indeterminate form. So you do something else. What? That. In this case, for example, from the entire polynomial, which is the x with the highest power?
3.
Not the coefficient. This. So, limit x approaches infinity of, it says, I need to factor that x to the cube, and the rest divided by that. So it means that I'm going to leave the x to the cube outside, put a parenthesis, and divide every term by that x to the cube. 3x to the cube over x to the cube. 2x squared over x to the cube plus 1 over x to the cube. Okay? This is different than in the rational. Because in the rational, I just divided everything. So it doesn't change anything. I'm just rewriting the function. In this case, I'm factorizing because I cannot just disappear the x to the cube. A ver.
No, sí tenía, eso
Me pueden llegar a preguntar, es que va a ser lo mismo. No, aquí la idea es que, por ejemplo, aquí dividí entre todo y no lo puse afuera. Y ahí sí lo puse afuera. ¿Por qué la diferencia? Porque al dividir entre todo, arriba y abajo, se balancea la función. No se pierde nada. Si es una polinomial, como no hay denominador de la polinomial, si nomás lo desaparezco, se desbalancea la función. Por eso lo estoy factorizando. Factorizar al factorizar, lo demás lo divido. Es la única diferencia. ¿Ok? Limit x approaches infinity of x to the cube. Divide, simplify. 3 minus
2 over x
plus
1 over x.
and then evaluate again. Evaluate infinity to the cube 3 minus 2 over infinity plus 1 over.
todo va a ser infinity.
That's the idea.
No, pues.
This becomes what? 0, 0, and then you have infinity to the cube, infinity times 3, infinity, and that's an answer.
Okay. And what if it's like infinity plus infinity?
Then it's infinity and that's it.
Okay.
So the problem when you have this,
Negative.
infinity minus infinity, or something similar. Let's say that tomorrow, I'll do a little more. In rational, you can have a number, like the one that we did at the beginning, 0, or plus or minus infinity. In the polynomial ones, it's either infinity or negative.
So, this one, if it was with the negative, like the limit is a negative infinity, the answer would be negative.
That's the difference between this one and that one. That one I didn't factorize, so you divide everything. But in this one I factorize and divide everything. You balance the functions.
Infinito por infinito, infinito.
Questions? No? Si mantiene minus 10 plus Okay, before you go, listen, tomorrow, bring activity 2.3, the next one. We're going to be working with that in class. It's about this. And also, this is basically the long procedure. Okay, it's a short procedure for this. I'm going to show you tomorrow. Also, I'm going to use that just to verify, because they're going to do the whole process in the exam. So, again, tomorrow, activity 2.3, and Friday,